particle is moving along a curve. XY plane has this position, xt, x of t, y of t at time t, measured in centimeters, and x prime of t and y prime of t have been given. X prime of t and y prime of t, the velocity at any time t. So at time t 2 seconds, the particle is 0.36. So this is where the particle is at. X value 3 and y value 6 is a position at time t equals 2 seconds. So let's just say pretend that this is the curve that the particle is moving on. Then the velocity vector at that point is the slope at that point, which is given by this velocity vector v. And then this velocity vector, of course, since it's on a curve, it has an x component, x prime of t and y prime of t. Okay, so basically the y prime of t, of course, can be moved to out here. So now you can see that x prime of t and y prime of t, and that's our velocity vector, the total velocity vector. Okay, good. So first thing, we have to find the speed of the particles. So speed is the magnitude of the velocity vector, okay, which is the absolute value of the velocity vector is the speed, and is given by this formula square root of x prime of t whole squared plus y prime of t whole squared. And now you can see where this is coming from, because this is the Pythagoras theorem. This is the x component of the velocity vector, this is the y component of the velocity vector, and then in order to get to the velocity vector and the magnitude of the velocity, which is the speed, we are going to use the Pythagoras theorem, which is right here. And so we are interested in position time is 2. So first let's go ahead and calculate that at time t is 2 for the x prime of at 2 is 8 times 2 minus 2 squared, so it's 12 centimeters per second. That's the x component at time 2. And the y component at time 2 is given by substituting 2 in this y prime of t. So this is going to be negative 2 plus 2 to the power 1.2 plus 20. So you can go ahead and use your calculator to calculate that. I just showed you some calculations here. Negative 2 plus 22.3 square root of that, which is approximately coming to 2.72 centimeters per second. So the speed, which is the magnitude of the velocity vector, is given by the square root of x prime of t whole squared, which is this 12 squared, plus y prime of t whole squared, which is 2.72 squared. So we take this, and then we can go ahead and simplify inside the radical. 151.4, approximately 12.3 centimeters per second is the speed of the particle at time t equals 2 seconds. Okay, all right. I hope you enjoyed this video. Please let me know in the comments below. If you have any questions for part 2, which will be coming up, please look out for that. Thank you. Have a nice day. Bye.